This is the summary, and we look at a series of the symptoms, including discomfort, dryness, itchiness, burning, etc., redness, tearing. And you can see that the percentage at baseline compared to 6 months, not much difference, right? So most of them actually decrease. If you look at the figure, the percentage, it decreased or no change with lens wear. So there were no significant change in frequency or severity of symptoms. And most of them, even if they reported the symptoms, it was very mild to mild, and occasionally, not all the time. And of course, we also look at during the daytime symptoms and at the end of the day symptoms, and the result was similar. So if we look at, if you have been practicing contact lens for a long time, you know that the two most common reasons for soft contact lens discontinuation are discomfort and dryness. But if you look at the results that we have, we can see that they actually with ortho-K lens wear using this particular solution, they are far less frequently reported. And this, the serious adverse events were already observed in ortho-K lens wear. This has been reported before in our previous studies, and also in Jacinto's study in 2012, the MCOS, I think. And this might be because ortho-K lenses were only worn at night, so there is a minimal effect on the tear film due to evaporation and incomplete blinking. In terms of signs, we also look at a series of them, including corneal staining, congenital injection, and we also, I'm not sure about in the Caucasian children, but in Chinese children, we seem to see a lot of follicles in the lower lid, but they gradually change over with age. So there's a small percentage of subjects presenting signs, mostly, again, very mild to mild, and there's not much difference between baseline and at a 6 months visit. Statistically, there were no significant changes. So if we look at corneal staining, it is not an uncommon sign in ortho-K lens wearers, and most of them, we do see them, especially at the beginning of lens wear. And in 2018, ATL actually reported less staining in soft contact lens wearers, also using povidone iodine-based soft contact lens solution compared to those using other products. And they also reported significantly better end-of-day comfort. Although they did actually notice some slightly more low-level itchiness. So the results of the current study using RGP solution were in agreement with the 10 et al. Study, and we suggest that povidone iodine-based solutions are not associated with any increased signs and symptoms. In our previous studies, actually, we have a number of papers that we reported previously in the same, the overall project. We have found that the povidone iodine-based MPS, the BG lens solution, were effective against FDA panel of organisms. It's also the solution is also significantly reduced the level of Acinetobacter castellani. And it is also very effective in preventing and disrupting biofilm in lens cases. And it also did not affect the ocular microbiome. And the most important also, we noted that there is no report of development of bacterial resistance to iodine. So there's no loss of solution effectiveness over time. So in conclusion, povidone-based iodine solution has little or no change in both signs and symptoms, and both in terms of frequency and severity. So there's no increase in overall discomfort, so it's a suitable alternative to MPS, especially those presenting with solution sensitivity. Thank you.
Thanks, Pauline. We have to move on straight on, I think, to the next talker. Takashi is talking about the improvement of soft contact lens wettability after using lens care solution with hyaluronic acid derivatives.
Thank you. I will talk about the improvement of soft contact lens wettability after using lens care solution with a hyaluronic acid derivative. The optics measure the contact lens angles. So, as you know, the CLD contact lens difficulty is a condition characterized by historic or persistent adverse ocular sensations. A lot of people are aware the dropout and discontinue due to the CLD. So, risk factors of CLD may include the material and design of the CL along with the environmental factors. we speculate a better lens surface vitality may improve the CLD. Optics developed a new material and HAD, hyaluronic acid derivative. Lens treatment using HAD, low molecular weight hyaluronic acid derivative HAD, based on a solution, leads to the improved in vitro lens hydrophilicity. So, a purpose of this study is to compare tear film stability on the lens surface in vitro and subject symptom between the use of the multi-purpose solution, MPS contained HAD, HAD plus and HAD minus. So, participants, including 10 female who complained of the dryness when wearing SGL, was enrolled. They use lens care. One is HAD plus, Clear Dew Repair Moist, just a previous version of Clear Dew MPS. And HAD minus is Renew First. Each solution was used for 2 weeks each. Examination, such as a non-invasive breakup term NIBUT of tear fluid on the lens, was measured with ZR1 alpha. Also, we asked the subject symptom using the JCLD-EQ8. Wettability of used lens is take the contact lens angle, removed shear with measured. I show the data. The NIBT after only HAD minus care was significantly shorter than that before HAD minus care. However, HAD plus doesn't change the NIBT. And also comparison between the HAD minus and HAD plus. NIBT after HAD plus care was significantly longer than that after HAD minus care. Contact lens angle after HAD plus care was significantly lower than that after HAD minus care. So the wettability also improved. So I asked the subject symptoms using JCLD-EQ8. HAD minus, there are no change. However, using the HAD plus and JCLD-EQ8 after only HAD plus care was significantly lower than that before care. So conclusion, the care system including the HAD could maintain the tear film stability on SGL while care use and improve subject symptoms. So care system including the HAD may be an option for prevention for CLD and also the discontinue of the contact lens. Thank you for your attention.
Thank you very much. We do have time for a couple of questions on this one, if there are any questions. Your subject group seemed to be quite high on the CLD-Q8, so you enrolled only symptomatic subjects, was it? Yeah.
Yeah. Yes.
And did it go down? Did it bring it down to becoming less asymptomatic or just less symptomatic?
Less symptomatic.
Less symptomatic. No other questions? We'll move straight on then. I think, Lyndon, you're up next. You can come this side if you want, whichever side you want. Okay, Lyndon's going to talk to us today about fabrication of a microfluid chip for evaluating drug delivery and ocular toxicity with contact lenses.
Thank you, Mark. So I'd like to begin by thanking the people who actually did this work, Brandon, Megala, Alex, and Chow, and also to thank the sponsors of this work that we do at CORE. So CORE currently works with all these companies, but this is very much a generic talk talking about a new way of being able to look at the interaction of novel formulations with human corneal epithelial cells. So we know that current methods for ocular drug delivery suffer from a variety of complications, including poor efficacy, low bioavailability, poor compliance, and many of them have risks. For example, intravitreal injections involve some risk of infection. So there's a very high demand for novel drug discovery and delivery approaches, and what we're starting to see is a growing use of things called lab on a chip, and these milli and microfluidic devices really are at the forefront of therapeutic discovery. And so we're seeing a number of publications now coming out using these devices for novel drug discovery, and in particular in trying to understand the interactions of these novel drugs with body tissues. Now, the advantages of using these micro and millifluidic devices are that you can decrease the consumption of the reagents that you're using, so you reduce the cost of the drug discovery. You're able to increase assay throughput significantly, so speed up the drug delivery and discovery process. You can custom design what you're looking at and also capture the interactions of these cellular tissues with whatever things you're looking at, whether it's, say, be either drug discovery or drug delivery. So our objective was to basically develop an inexpensive PDMS microfluidic device to look at ocular toxicity with ophthalmic formulations. Now, the beauty of using PDMS is that it's transparent, so you can look at how these cells are behaving through using normal microscopy methods. And also, because PDMS is permeable to gases, it enables you to use a wide variety of ocular tissues. The downside is that it's blooming expensive. So it's very expensive and you need very expensive equipment. So for example, the 3D printers that you use may cost upwards of $200,000 each. So not many labs can actually do that. So our aim was really twofold: to use commercial 3D printers to generate optically transparent microfluidic devices, and then basically incorporate into these microfluidic devices human corneal epithelial cells that we could visualize and see how it is that they're reacting to these formulations. So two processes. The first one is to actually develop the microfluidic device. So the way in which you do this is that you use a 3D printer, and this 3D printer basically produces your mold, and then you pour resin into these molds and create your microfluidic device. Now the problem is that when you use commercial 3D printers, and we were using 3D printers that didn't cost $200,000, they cost about $300, so you can imagine doing this really in a wide variety of labs, is that they don't produce very smooth surfaces. So sadly, they're not as optically transparent as you'd like them to be, and you can see that in the bottom graph on the left-hand side. So we developed basically a process whereby you polish this surface and then fill in that 3D printed mold using actually nothing more than the transparent nail polish, and that produces a very optically transparent, a very smooth surface that then when you pour in the resin produces a very, very smooth surface that is optically transparent. You can see that in the bottom middle picture, just how transparent that is. So very, very cheap way of producing the microfluidic device. The next part then was to incorporate cells into that, and that took a long time because it's actually quite difficult to make those cells adhere to the surface. So we actually ended up producing a process where we treated these devices with polydopamine that enabled us to grow a very confluent layer of cells within about 24 to 36 hours. And when we looked at the viability of those cells, they were certainly as viable as ones that you would be able to purchase in far, far more expensive commercially available tissue culture devices. The way in which we're using these is really twofold. The first is that we would use these microfluidic devices with the cells incorporated. We would flow over the solution of interest and then collect the elute from those cells, and being able to look at what, for example, inflammatory markers it is that they're releasing. Or the second thing is that we're able to actually incorporate these in series, where we would, in the first situation, have a drug delivery device that then releases its drug into a secondary device where that flows over the cells, and that enables us then to look at how those cells are performing and behaving. Here's the current setup that we have, and so we have been able to develop a very inexpensive way of being able to look at these drugs flowing over human corneal epithelial cells, and we've been using these to look at, for example, things like traditional Chinese medicines and how they interact with cornea and retinal cells, and also a wide variety of other drugs and other contact lens solutions as well. So with that, I'll say thanks very much, say to the people who are doing this work, and thanks to the Hong Kong government and the funding agencies in Canada as well. Thanks very much.
Thanks very much, Lyndon. Bang on time. We'll move on, and I think it's me next, so I won't bother to introduce myself. Just wait for the slides to come up there. So today I'm going to talk about the cytotoxic strains of Pseudomonas, and they're being much more likely to be resistant to antibiotics. I guess this is taken on a bit more significance these days with the outbreak of keratitis caused by Pseudomonas contaminating ocular drops in the United States, which has even led to at least 4 deaths so far of patients, several enucleations, and many people having lost vision. So Pseudomonas is still the most common cause of contact lens associated microbial keratitis. As you're sure you know, treatment is usually monotherapy with fluoroquinolone or a fortified gentamicin, typically given very frequently in the first 24 hours and then tailored off during the course of the disease. It's very difficult to get sometimes